Hello guys, I hope you're doing fantastic. We have a question over here. We are given that cos of A minus B equals to cos of A cos of B plus sine of A sine of B. Now in this question we are required to use the above identity to deduce that sine of A minus B equals to sine of A cos B minus cos of A sine of B. It's worth 3 marks. Now, looking at these two things that were given, cos of A minus B and sine of A minus B, these two angles are the same. It's A minus B, both of them. The only difference is that one is attached to a cos and the other one is attached to a sine. So basically, we are changing cos to sine. Now, the thing that allows us to change cos to sine is cofunctions. So we can say, okay, sine of A minus B is the same as saying it's cos of 90 minus A minus B. Right. I've used cofunctions. Now, what I'm going to do now is that I'm going to say cos of, this is going to be 90 plus B, because this minus multiplies the A and it multiplies the minus B as well. It gives me positive B, and then I have the minus A there. Now this one for 90 plus B, I'm going to just bracket it out so that it acts as one angle. So implying that it's like when I go back to this over here, I have cos of A, but then instead of my A, it's the 90 plus B. And then I have minus B. Instead of the minus B, it's actually minus A. So this 90 plus B, this 90 plus B over here acts as a single angle, implying that it's going to be cos of 90 plus B cos of A. I'm following this over here. Then I have a plus. It becomes sine. Instead of A, I'm going to say 90 plus B. And then sine of, instead of the B, it's going to be the A. Alright. So now, looking at this 90 plus, when we speak about 90 plus, we are in the second quadrant. This is 90 plus, right? And in the second quadrant, only sine is positive. All the other trig ratios are negative. Only sine is positive, implying that when I say cos of 90 plus beta, because cos is negative in this quadrant, the answer is going to be negative. But then because I'm using 90 to reduce, the cos will change to sine. So this will become minus sine of beta, or rather of B, and then cos of A. Now when I look at this sine of 90 plus beta over here, 90 plus beta second quadrant, sine is positive. So this is just going to turn into sine of B, and then multiplied by sine of A. When I put this in a manner that they would like, let me erase this so that we can see the similarities between these two. So I'm going to put this one first, starting off with sine of A. So it's going to be sine of A, sine of, oh my bad, forgot one thing over here. Remember when we were over here, sine of 90 plus beta, 90 plus second quadrant, sine is positive, but then the fact that we're using 90 to reduce, right, we're going to change sine to cos. So this over here should be cos of B, right? Just a little tweaking. Then rewriting this properly, it's sine of A, and then I have cos of B, and then minus, I'm pulling this one now. I'm going to start off with cos of A and then sine of B. Now I've proven, if I just take this down, sine of A minus B equals to sine of A cos B minus cos of A sine B, which is exactly what they wanted me to prove.